Hi, this is Amy, and welcome back to OpenStack Magnum Containers, an overview of containers with OpenStack and Magnum. Where exactly do containers fit in OpenStack? Cloud infrastructure provides a complete data center management solution in which containers or hypervisors, for that matter, are only part of a much bigger system. Containers provide deterministic software packaging and fit nicely with an immutable infrastructure model. Containers are excellent for encapsulation of microservices. Containers add additional portability within OpenStack on virtual machines as well as bare metal servers, known as Ironic, using a single lightweight image. One of the benefits of using an orchestration framework with containers is that it can allow switching between OpenStack or bare metal environments at any given point in time, abstracting the application away from the infrastructure. OpenStack projects that work with containers. The first is Nova. Nova contains a Docker hypervisor driver for Nova Compute to treat containers and images as the same type of resource as virtual machines. Heat. Heat orchestration contains a plugin template for orchestrating Docker resources on top of OpenStack resources. It allows access to full Docker API. Magnum, which is our focus of this course, Magnum provides an API to manage multi-tenant containers as a service, leveraging Heat, Nova, and Neutron. Cola, which is not covered in this course. Cola containerizes the OpenStack control services themselves as microservices to simplify the operational experience. Murano, which is also not covered in this class. Murano provides an application catalog of containerized applications that can be deployed to an OpenStack cloud. Where exactly does Magnum fit in? OpenStack Magnum provides APIs and tenant isolation for container orchestration engines. Complete management for containers within OpenStack orchestrates the underlying host machines with Heat, implements multi-tenancy of separate clusters through Keystone, provides multi-host networking with Neutron. It also supports several container orchestration engines, Docker Swarm, Google Kubernetes, and Apache Mesos. It allows direct access to native container APIs. Docker CLI clients can access hosts and containers. The Kubernetes client can also directly manage pods, services, etc. Containers are a complement to existing technology that bring a new set of benefits. OpenStack enables organizations to select and use the right tool for the job. OpenStack supports containers on bare metal or virtual machines as stated. Operators must be aware that containers don't have the same security isolation capabilities as virtual machines, which means that containers cannot be viewed as a direct substitute for virtual machines. As an example, service providers often run containers and VMs in order to provide robust protection of one tenant's processes from poorly behaved or malicious code in other containers. Another approach is to use a bay in OpenStack Magnum to arrange a group of virtual machines or bare metal instances that are only used by one tenant to address this risk. OpenStack supports all of these configurations in the role of the overall data center manager. Virtual machines deliver compute resources and containers, aid application deployment and management. For many organizations, containers on OpenStack enable additional flexibility and deployment agility without having to spin up a separate container-only infrastructure. Now let's take a more in-depth view of Magnum and OpenStack. In this slide, we see how the different pieces of OpenStack interact to create the Docker containers. From the Magnum client, commands are sent to the Magnum API, which then communicates with the Magnum conductor. The conductor can then talk directly to the Docker API, the relevant COE, or to Heat in order to fulfill the request made to the client. Use cases for containers in OpenStack. Developers can create an application container containing the app, runtimes, libraries, etc., and move it to any machine, physical or virtual. In CI/CD environments, Containers enable organizations to rapidly test more system permutations. For quality assurance, containers enable better black box testing, as well as help organizations shift from governance to compliance. Containers can be created using a single consistent container image, and changes can immediately be layered upon all the container instances. Containers can be run on different underlying hardware, so if one host goes down, administrators can route traffic to live application containers running elsewhere. And that concludes where containers fit within OpenStack. Let's go ahead and click Finish and move on to the next lesson about where we talk more in depth about Magnum.